Hello. So this presentation is a companion presentation to a document for this year, and addresses a number of harvest policy considerations. In this case, in particular, to what has been discussed earlier regarding the pattern of the retrospective issue and potential ways of factoring that into the current harvest policy. So this slide shows the history of target harvest rate from 1984 to effectively this year. And several things has to be noted is that although we do not have currently a formal coast-wide harvest rate, the reality of the development of the target harvest rate was thought or developed from the one that we have now from what was considered the core area of the stock. And now the actual target, if you will, coast-wide harvest rate is a combination of the target harvest rates that we have for areas 3A East and 3A West. And why that happened is what I'm going to explain in a second. We just focus on the overall target harvest rate, the one that was developed by the harvest policy at different times, has come down from a high in the 80s and early 90s of 35% of explorable biomass. At that time, they were using a different estimate of natural mortality, and it was brought down in part to changes in natural mortality and other considerations regarding the assessment. A change that happened in 2006 was that some areas, including 4B and 4CDE, were considered area of specific concern, and this was based on changes in indices of those areas, particularly the survey and changes in age composition, for example, and that resulted in a reduction from 0.2 to 0.15. In 2008, 4A joined the set of areas of concern, and the same reduction of 0.15 was determined for 4A. And 2010, the area 3B also joined the set of areas of particular concern, and the reduction into 0.15 target harvest rate. Beginning this year, although this seems like an increase in target harvest rate, that is not so, because effectively that was a different way of factoring the fraction that is over 26 inches and under 32 inches. So effectively, the target harvest rate is equivalent. We just redefine what the explorable biomass is. In terms of where we are with the most current estimates of coast-wide realized harvest rates compared with what the targets were, or what the implied target is, because now it's no longer 0.2 coast-wide, now it's a combination of a 0.2 and the 0.15, which is basically typically around 0.19, 0.18 each year. Irrespectively of that slight difference regarding what is the target harvest rate, we can see that we've been overshooting that target in some of the years by as much as, in this case, will be around 50% of what the target was, 0.2. In this case, I think it's like 0.32. We're going to get to specific numbers in the next sets of slides. A couple of points to make very clear here is that given the retrospective pattern, the estimates of how big is that departure changes from year to year. That is, when we set quotas, we believe we're setting them close to the target, and then when the original biomass gets revised down, the catch was already taken, so that number does not change. We're just dividing by a number that is smaller. So this is going up, has been going up each year. By that metric, the earlier estimates of realized harvest rates are the ones that are more imprecisely estimated, and the ones that are expected to change more into the future.
So can I ask a question? Yes. So if the retrospective thing continues and we try to produce this chart next year, will those realized harvest rates be higher than the show here?
Well, it's hard to know what is going to happen next year, but what we can say is what has been happening since 2004, and each year has been consistently down. So if we were to bet on what happened next year based on what happened in the past 8 years, somebody can say, well, yes, that would be the case, but we don't know if the pattern will continue. If we continue to do the same things that we've been doing in the past, and the pattern continues, it is expected that those harvest rates will be revised upwards. Does that make sense?
Yes, thanks.
So the previous slide was in terms of departures between realized harvest rates estimated from this year and target harvest rates at the coast-wide scale. This is other departures from realized harvest rates and target harvest rates at the area-specific level. So this column here that says CW is coast-wide, and is the same series that you saw in the previous slide that was in white bars in that case. So this goes from 1997 to last year, 2010, and it shows that pattern that we were saying before. Coast-wide, the target is somewhere, the implied target, if you will, close to around 0.19, and for some years it has been higher. These are all the other areas with the respective target harvest rate. So point to note, as was mentioned in previous presentations, particularly in area 2, there has been a large departure between realized harvest rates and target, and we can see after this, the last year of the closed area assessments, and after the implementation of the coast-wide assessment with solid partition of biomass, we see a decline of realized harvest rates for a particular assessment, right? Because these numbers get revised up every year. So things like this have been revised up every year, at least since 2004. Why we have two panels here is just one without adjustments on the survey, and this one is with adjusting for hook competition and survey timing. So this is as far as I will discuss regarding area-specific departures. The focus of the presentation is on the coast-wide total. So
Can you go back to that a minute? Because maybe I'm just having trouble. Oh, I think I'm just having trouble. It's okay. Having trouble reading that last bar. Because it's looking like everything isn't behaving the same way, but maybe it's just I'm having trouble seeing the colors.
Yes, a lot of data in that should have used a different color pattern for the last few years.
Between 2B and 2A, like 2B is going down year by year, but 2A is up.
Yeah, I have a question, Ms. Phillip.
Yep.
Without adjustments and adjusting for hook competition and survey timing, I don't understand as far as to the stock is concerned, and the big reductions that are recommended right now, or the cuts. The adjustments, without the adjustments, would the cuts be less or more than staff recommendations right now? Or are the staff recommendations lower because of the hook competition and survey timing?
The point of this is actually to show that although you may see some differences in an area-by-area departure, say between target and realized, that happens only within areas for a particular year. So the adjustments have no effect, no discerning effect in the overall coast-wide trend in departures between target and realized harvest rates. So that is actually not factored in the analysis. It's only focusing at the coast-wide level. So the adjusting will not influence to measure this type of proposal or alternative adjusting the target harvest rate.
I think when we've looked at these in past years, and I recall that in British Columbia, 2B, the peak used to be 60%, but these have been adjusted up now because of the retrospective behavior,
That
right?
is
And
correct.
so these might even come up slightly more to that peak here. It's over 70% there.
If the pattern of retrospective the retrospective issues is still present, say this year, it is expected that it will be there. That departure will be similar to what we see now.
But they start to converge. They start to converge after, you know,
We'll see.
things. So
We'll see some spice.
I don't know. I guess my point is I don't know if those particular ones with the peaks will change that much.
The farther they are in the past, the less they're going to adjust.
Right.
In theory, that's what you're expecting. Effectively, is when you have the whole dynamics of this is that when you have only one look at an incoming cohort, you only have a single look, and they're barely selected to your year. The next year you have two look at it. The following year you have three. So the farther on you go, the better look you have at cohorts that are entering, and overall the combination to the explorable biomass. Since we have a broad set of ages in a long-lived fish, then it takes quite a few years to actually allow to have the look, if you will, to the real magnitude of that cohort, the close we can get. This is the retrospective pattern as of last year assessment, so end of 2010. And what this plot is showing on the upper panel is the differing trends of explorable biomass as estimated from the first assessment that I'm showing here is the assessment of 2006. The pattern has been going in this consistency since 2004. And this is slightly different from what was presented in Steven's presentation, in as much this is the real time series of estimates that were produced in 2006. So there are two ways of looking at retrospective patterns. One is the historical one, which is this one. The other one is the sequential, which just is the last year's assessment, and you drop 1 year of data. So they produce slightly different results. This is basically where we set quotas at in 2006, 7, 8, 9, 10, so forth. What we see as solid lines here is the estimate up to the last year of assessment. What we see as dotted lines here are the 5-year projections that were done in this year. So we see that each year, subsequently, the initial biomass that was estimated, say, for the year where we said catches, it gets revised down. As Steven mentioned, there was a year there between 2007 and 2008 where the reduction was not so much, and actually the time series of estimates overlap with the previous ones. However, the pattern came back as of the end of last year. This was the estimate that we have not only of the last year, but of all of the previous years, and the 5-year biomass projections with some of the statistical uncertainty that was mentioned earlier. In this case, statistical uncertainty regarding future recruitment.
So this is a year old, though, right?
This is a year old.
So if you take that bottom line, the last point is a projection, and where it turns there is probably 295 million pounds. But now we're hearing that it's probably 245.
We're going to see slides on that in the next slide.
Okay.
So this pattern is for the exportable biomass. That is the pattern for the spawning biomass.
But it looks like it's a lot tighter for the spawning biomass, or less of a retrospective pattern.
It is different on the last year, particularly it does not have that steep uptake in the estimates of the last year. And we're going to see the magnitude, I think, in the next panels.
Okay.
So this was as of end of last year.
Yeah.
This with the updated numbers for this year. So the pattern is still the same in terms of the update in the last year or last few years, estimated update on it, and then the pattern of revised down biomass. As mentioned earlier, the last year's estimate of eBio was revised down as a whole 25%, but part of it is due to change in the input data regarding commercial CPUE. But effectively, we said the catches at a number that now came down 25%. Part due to retrospective pattern, part due to an updated data set.
But this is also using a different parameterization? We're using WOBLE as
No, I'm
here?
just using all the same base cases it was used last year
Okay.
for comparison. So we actually called the fish based on these numbers here, and this number here has not affected yet the dynamics of the stock. So it's still comparable as well. So the pattern is not only affecting the estimates of explorable biomass, in this case in triangles in blue, and spotty biomass as pink squares, but it's also affecting the estimates of total biomass. So we can take any of these years, they also come down, and those uptake can actually be downwards increase years down the road. Again, this is as of last year, this is as of this year, so it's the same pattern in trend, and depending on the year, it could be a larger decrease on the last year, so change from last year to this year. So it's difficult to look at these things other than the overall trend. So another way of looking at this problem is looking at the how that first look that we get at each explorable biomass, and that's where we set the quotas at, gets revised each subsequent year. For example, the assessment that was done in year 2004 produced a 2005 estimate of this number here, which is about 425 or so, no, more than that, 440 say. I mean, I want to be specific because I cannot read this graph to that scale. Irrespectively of that, the following year, 2005, gets revised down, so 112 until it gets somewhere to this level. So this has happened to every explorable estimate. This is 2005. The pattern has been consistent with some variability, as was mentioned before. So to put this in relative numbers, we can take the first estimate, which was the largest for all of this explorable biomass, and plot this in terms of a change relative to the initial estimate. So 1 is the first year that was estimated, and then this is like the fraction and percentage that has come down each year. So the 2005 estimate was revised down by 10% in 1 year. For example, this one was slightly less. The one in 2007 by 20%, and so on and so forth. So this is this year's estimate. If you want, we only looked at it once, so we can know what is going to happen. But then again, this is as of last year. So this year, that's the pattern that we see again. So as was mentioned before, you would expect that those declines at some point will converge. Basically, at some point we're going to say, well, we overestimate those explorable biomass by a number, and that's more or less fixed. Although we can see that some of the large changes in the first year, some of those estimates, it's not there in the last year in terms of the magnitude. For example, last year, this is a 25% coming down from the value that catches were set. In the last year, it's not 25, but overall, the pattern is still declining for, say, 2007. So it's not as steep here, but still declining. Yes.
So the 2000, our understanding of the eBio on the grounds in 2004 continues to decline. So last year we thought it was at 68% of what we thought it was in 2004. This year we only think it's at 62%. So that's how to interpret that?
That is correct. So if we come back to last year, we can say we can be as low as 30% of one of the oldest estimates.
So that declining line slope doesn't seem to be changing that much. And if it's so next year we probably will be at 52% or whatever. But if that slope is staying the same, well, maybe I'm looking at I looked at the wrong line.
So that's the line. So
okay.
You can say there's no change in the slope between the second year that it was estimated and this last time. The first year was steeper than that one.
I see. I thought that was the continuation of the blue line. So I understand now. But my question was going to be, when we look at those patterns from that show the whole year from 2004, it doesn't. It seems like they converge a little bit, so you have less of an impact each year. But this would seem to suggest that you have the same estimate of continuing decline, even of the old year classes of the old population. I probably haven't said that very well, but
no, what you're getting at is like these are expecting. If I can rephrase your point, you're expecting that these declines will at some point converge. However, for some of those cohorts, there's not an indication of convergence beyond the second year.
and I guess my expectation that they might converge was because the very first slides you show with that series of lines, seems to me they converge, but maybe I just looked at that wrong.
This one?
No, it's back about 5 or 6. Those.
That one here?
Yes, because when you go back to, I see, so that's way back at 2000, so we no longer get any changes of what we believed was there in 2000. That has stabilized. But when we're looking at 2004, I can see that it still dropped. Okay, thank you very much. I have that.
But it does tend to converge.
Well, I thought it would, but it surely doesn't seem to be converging in these slides. The slope's not changing.
Well, I think if you follow individual ones there is some variation.
So the first one can be the largest one, like for example, this year you dropped 20%, and then you drop like about 4, another 5. I mean, it's hard to make things, but it's almost like 10% or 8% in the last year. So it all depends on how you read this thing. This line will be 1, 2, 3, 4, 5, 6 points. If you take one, you take this one out, this is increasing slope or no slope. If you put that on, it's hard to know.
It would seem like that slope should get less and less.
Yes.
One would expect that it would come down to some lower limit that it couldn't go beyond. I mean, if the slope's not changing, then there's something wrong with the data because it can't get to 0.
The data.
I mean, the slope. I mean, if that continues into the future, those lines will get to 0, which is.
Well, they have a limit. We know that there was at least. It can't be 0 because there was at least the amount that we took.
It can't be 0 because I fished those years and there was fish there.
Exactly. But it's showing a decline, and as Bruce mentioned, it changes between years. However, at this stage, from my perspective, it's hard to predict this, for example, or any of the other ones as a converged series or anything along those lines. So we're not predicting here anything that will happen next year. It's just saying what we're last year and the previous years and where we are now.
Well, I'm with Gary. I think we can predict that line can't continue to go down at that rate.
Or there's something else that's involved.
Yeah.
So then, at any rate, the farthest it has dropped for so far is around 39% of the original estimate in 1, 2, 3, 4, 5 years. So this is not only affecting the trends on explorable biomass, total biomass, but also in spawning biomass. And this has an effect on the performance of our harvest policy regarding the reference points that we use. So just a quick reminder of what we're looking at. Here, this is the time series of explorable biomass estimated by this assessment. And in this case, this is for the base 2010, so not the wall, but it doesn't change much from it. This value here is the estimated the virgin explorable biomass, and then the 30% and 20%. Just a reminder of people, this area between the it's called between the threshold and fish level is you can call it the green area where we apply unmodified target harvest rates. The area that is in yellow there is an area of caution between the threshold and the limit. And the limit is an area where effectively following the current harvest control rule we will cease to fish or decrease the harvest rate to 0, following the current harvest control rule. So what this shows is that for 5 years, 5 consecutive years between 2005 and 2009, we had dropped below the threshold. So following those years into our harvest control rule, this is basically we compute each year where we are, we enter through here, we see in which area we are. If we're green, we apply the full target harvest rate. If we are yellow, we start to decrease our target harvest rate, depending on which level we are. So if we map those years into our harvest control rule, had we known that we were down at that level, then the reduction in target harvest rates would have been in the order of 18.6% to 14%, which is the year, in this case 2007, that retrospectively you can see that we can estimate that we were at that level. Again, these estimates have been coming down from the previous figure, right? So it's not that at that year we thought we were, in this case, 26% of unfetched. So that value, for example, the one from 2007, was estimated by the 2006 assessment as we being in, it should be SB, I apologize for the typo, in a 43% from unfetched level. In fact, years later, now we estimate retrospectively that we estimate that we were lower. And that's the level we are estimating we are currently for 2002. So ways of dealing with this pattern, there are ways of them which are saying, do we treat the symptom or do we treat the malady or the cause of it? So one way is actually to fix the retrospective pattern in the assessment, and as it was pointed out earlier, it's a complicated thing to do. Another way is actually to factor this into the target harvest rate, so try to be proactive to the problem. So the first approach is to decrease the target harvest rate as a function of the consistent harvest revision that we've seen for years past. So this was again based on last year's, and that is, if we assume that at least we've seen a reduction of 30%, then based on last year's data, we can apply a 30% revision down of the target harvest rates to account for the overestimation of those exploitable biomass as of last year. Using this year's results, we can see that we thought it was 30% last year. This year is down to 39% of the 39% lower than the original estimate, and that's if you adjust the target harvest rates down by the same amount, you get those values. It's important to note here that this is not a modification of the target harvest rates, but it's an adjustment so that we're actually getting closer to achieve those target harvest rates. Because applying those harvest rates is to something larger than intended, or has led to something larger than intended. So that's the first approach. The second approach is to look at the departures between the realized harvest rates themselves and the target. And this one incorporates other things such as changes in the implementation of the target rate itself, implementation errors on catches, how much catch takes here, but they are overall very similar. So in this case, we can take the highest departure we've seen so far, which is 32% intended to fish at 0.2, and as of this year, we estimate that we've been as high as 32%, which is 61% higher than the target. And these are other years, more recent years, as I mentioned. So we can use a working value at 32% departure from the target, and again, we revise down those target harvest rates, and we come back again to values that are around 0.13 for the areas that are using now 0.315 and 0.10 for areas that are having a target of 0.661. I think Bruce covered some of this in this presentation. It's just a potential waste. This is not a decision table, but also a contingency table on how, because we don't know what is going to happen. It's going back to the the earlier question, what happened next? What is going to happen next year? We're going to continue to have a retrospective pattern in the same direction or not. And these are two potential management actions. So in the short term, if we adjust those targets, we expect to have a modest yield, so smaller than, say, last year, or smaller than we will get if we use the current and adjusted target harvest rates. That's in the short term. In the long term, if the overestimation continues and we use the adjusted target harvest rates, we're trying to compound, to cure the symptom, if you will, and we will expect to have modest yield as well. On the other hand, in long term, continuing to apply under the same conditions, if the overestimation continues, that could lead to a conservation risk, given that we get higher than target harvest rates, and we seem to have dropped below our threshold. These are other, of course, this is the only thing we can decide. We don't have a decision on this, whether it will happen or not, and these are the other options. So if long term we find out that the retrospective issue disappeared, we can return to the unadjusted target harvest rates. In the other hand, if there's no retrospective issue and underestimation or underestimation starts, well, we get a much higher yield levels. And I think I probably should stop there because all these things that were covered in this presentation.
Thanks, Mark.
Thanks.
Okay.
There might be questions, but we weren't bashful about asking them during your presentation, so maybe there are no more.
That clears things up, though.
Okay. At this point, I would suggest we sort of end the webinar. Okay, so those folks listening on the webinar, that's the end of our presentation for today. Thank you very much for your attention.